Hi there, let's take a look at this first question here. So it says 7 years ago Roger was 5 times Larry's age. 4 years ago Roger was only 3 times Larry's age. What is the present age of each? Okay, so what we need to do is we need to create some equations to solve this problem. But before that we need some variables that we're going to use. And usually it's in the question that you can determine what your variables should be. So it says what is the present age of each? So those are going to be my variables. So I'll let R be Roger's age now, and I'll let L be Larry's age now. Okay, the next thing I have to do is I have to set up equations, and I do that by taking these sentences and translating them into mathematical symbols. Okay, so 7 years ago Roger was 5 times Larry's age. Okay, so this word was is going to be like your equal sign. Okay, it says Roger is, the price is, that's your equal sign. Here, Roger was. So, we're talking about Roger's age, but not Roger's age now, but 7 years ago. So I'm going to take Roger's age now and subtract that by 7. Okay, so this is Roger 7 years ago was, so equals 5 times Larry's age. But remember, this was 7 years ago. So we're not going to use L, we're going to use L minus 7. Okay, now it's important to put that in brackets because you're multiplying 5 by his age. This whole thing represents his age. Okay, so here's our first equation. Okay, but anytime you have two variables, you need two equations. So now I'm going to create a second equation, and here it says 4 years ago Roger was, so again Roger's age this time minus 4 years was, so equals 3 times Larry's age. So Larry's age 4 years ago is L minus 4. Okay, so this is what we call our system of equations, and now we have to figure out how to solve this. First thing we should do is simplify these equations. So I'll start with equation 1, and let's simplify it here. So what's easy to do is to isolate the R. So I'll leave the R on the left, and we'll bring the 7 to the other side. So this minus 7 will become plus 7. I'm also going to distribute the 5 here. Okay, so I just want to simplify it as much as I can. So on the right hand side we have 5L. Okay, 5 times negative 7 minus 35. Plus I'm going to bring this minus 7 to the other side, so plus 7. So equation 1, written in a simpler form, is 5L, and here negative 35 plus 7 is going to be negative 28. So 5L minus 28. Okay, let's do the same thing with the second equation. Okay, so here I'll do the same thing. I'm going to keep R on the left hand side. Here I'm going to distribute, so 3 times L, 3L, 3 times negative 4, minus 12. And then this minus 4, bring it to the other side, becomes plus 4. And so this equation here is 3L, negative 12 plus 4 is minus 8. Okay, so these are the equations I'm going to work with. So there's two ways we can solve a system. There's the elimination, which I think we'll see later on, and there's substitution. So here, this is Roger's age, that's Roger's age. So these two variables are equal. So if these are equal, 5L minus 28 and 3L minus 8 must also be equal, because they both equal the same number. So that means we can create an equation. So I'll go up here, and I know that 5L minus 28 has to be equal to 3L minus 8. Okay, but now what we've done is we've created an equation that has only one variable, so I can solve this. So bring the 3L to the other side, so 5L minus 3L, and here bring the minus 28 to the other side, so negative 8 is what I've got on the right. This minus 28, bring it to the other side, becomes plus 28. And so this is 2L equals negative 8 plus 28 is 20, and solve for L, divide both sides by 2, so L equals 10. So that means Larry's age is 10, so he's 10 years old. Okay, and now I can go back to one of these equations. I could use either one, because they represent the same number, to find Roger's age. So let's say I pick equation 2, looks a little easier. So R equals 3L minus 8. But now we know Larry's age. It's 10. So we have 3 times 10, 30, minus 8 is 22 years old. Okay? And there we have our answer for the first one. Okay, let's go down to number 2. Okay? 2 people share $1,560. One person has 1/2 of what the other person plus $150. What is the share of each? So again, don't worry, it sounds like a complicated sentence, but let's break it down. The first thing we need are our variables. Okay? What is the share of each? Okay? So let's call X share of person 1. Okay? And then we can call Y share of person 2. Okay? Use any variables you like. Usually X and Y are your default ones. Okay? So now let's read these sentences and translate them into equations. So they share $1,560, meaning if I take the 2 shares and I add them together, I get the total, $1,560. So there's one equation, X plus Y equals 1,560. Okay? So that's the easy one. Second one, need to do a bit of work here. So it says one person has, okay, this is your equal sign. So one person, let's say we call that X, has, so equals half of what the other person has. So half of what the other person, so if this is one person, Y must be the other person, half of what Y has, plus $150. Okay? And here now we have our system of equations. Okay? Now, here's a little trick that you can use. It's not great to have to work with fractions. Okay, so it would be nice to rewrite this equation so that we get rid of the fraction. So you take whatever you have in your denominator and you just multiply that to both sides of the equation. Okay, so this now becomes 2x equals, when I multiply 2 to 1/2, 2 times 1/2 is just 1. So I just have y, and then here 2 times 150 plus 300. Okay, so now I have an equation with no fractions in it. Okay, so this is where we now want to do some sort of substitution. So we have to isolate one of these variables. Okay, so let's say from this equation I isolate the y. Okay, so I got to bring this 300 to the other side, so it becomes minus 300. So it becomes 2x minus 300. Okay, this y and that y are equal. So I'm going to substitute. So now I'm going to take equation 1, and wherever I see a y, I'm going to substitute it with this expression here, because this is equal to y. So in this equation, wherever I see a y, I'm going to replace it by, that should be 300 of course, 2x minus 300, and I know that has to be equal to 1,560. So you see our goal is always to end up with an equation that has one variable. Okay, so let's solve this here. X plus 2x, 3x minus 300 equals 1,560. Let's bring the 300 to the other side, so 3x equals 1,560 plus 300. Okay, so this here would be 1,860. Okay, don't just use your calculator if you need to. And then here x is equal to, well, let me do it in my head here. So 18 divided by 3 is 6, so 6. 6 divided by 3 is 2. And then we've got the 0. Just to be sure, let me check. Okay, 1860 divided by 3 equals 620. There we go. Okay. Now, as we did before, once I know what x is, I can use one of these two equations to find y. So since y is isolated here, I'll use that here. So y is going to be equal to 2 times x, which now I know is 620. Okay, minus 300. So here, 2 times 620, that's 1240 minus 300. And so here, 1240 minus 300 equals 940. Okay, so this, the first person has $620, the other person has $940. Now, depending on what your teacher likes, sometimes they'd like you to write a sentence giving you giving the answer. So you would say person 1 has $620, person 2 has $940. Okay, so let's go on to question 3. Okay, and you'll see it's always the same thing. You come up with your variables, you write your equations, and then you can solve. Okay? So here it says a number is composed of 2 digits. Okay? So here, my number, okay, so 2 digits, so let's say xy. Okay, so x is the first digit, and y is the second digit. Oops. Okay. So the sum of the 2 digits equals 6. So I take my 2 digits, x and y, and the sum, so x plus y, is equal to 6. And there you go. There's equation 1. Then double the first digit. So equation 2, double the first digit. So it means x multiplied by 2. That's what doubling is. Okay. Increased by, that's another way of saying addition. Triple the second digit, so 3y, is equal to 16. Okay. What is the number? Okay. So if we find x and y, we'll be able to state the number. So here, because x and y are easy to isolate, I'm going to use equation 1, and I'll isolate one of these variables. So you take your pick. One isn't easier than the other, so what I'll do is I'll isolate x. So I got to bring y to the other side, so that's going to become 6 minus y. So now I'm going to take the other equation, and wherever I see x in that other equation, I'm going to replace it by 6 minus y, since that's what x is equal to. Okay, so 2 times 6 minus y plus 3y is equal to 16. Okay, and as usual, what we want is an equation that has only one variable. So let's solve this equation. So here, distribute the 2. So 2 times 6 is 12 minus 2y plus 3y equals 16. Okay, so here, negative 2y plus 3y is 1y, so y. And now the so since it's a positive, when I bring it to the other side, I'm just going to subtract the 12. So y is equal to 4. Okay, so there's one of my digits. Okay, now I can use this equation here to determine the x value. So here, x is equal to 6 minus y, but I know now that y is equal to 4. So 6 minus 4, x is equal to 2. Okay, but what they want is they want the number. Okay, so here the number is, well, the first digit is x, so 2. The second digit is 4, so the number. Okay, let's go on to the last question here. So Gregory bought 6 apples and 10 oranges for 74 cents. Sandy bought 15 apples and 8 oranges for $1. This must have been quite a while ago, because you can't buy this stuff for this price anymore. Determine the cost of 1 apple and 1 orange. Okay, so here, let's look at the question itself, and this tells us what our variables should be. Okay, so I'll call x the cost for one, what comes first, apple, and y is the cost for 1 orange. Oops. Okay. So let's take our sentences and try to create equations here. So, bought 6 apples and 10 oranges for 74 cents. Okay, so if x is the cost for 1 apple, and I'm buying 6 apples, the cost for 6 apples will be 6 times x. Okay, and so plus 10 oranges, so 10 oranges times the cost of 1 orange, 10y, that's the cost of the oranges, and the total is 74 cents, so 0.74. I'll leave everything in dollars. That makes, that's sort of the standard. So this now is equation 1. Equation 2, let's go to the second sentence. Sandy bought 15 apples, so 15 times x, and plus 8 oranges, 8 times y. and the total cost for both is $1. Okay. Now I'm going to solve this problem a little differently because none of the variables are particularly easy to solve for. So I'm going to use the other method for solving a system of equations, which is called elimination. So the idea here is I want to rewrite these equations so that I end up with the same coefficient, the same number in front of one of the variables. So I can either get the same coefficient in front of the x's or the y's. It seems a little bit easier to use the y's. Okay? So here I've got 10 and I've got 8. And I think, well, is there a common multiple of these two? And I go, well, the smallest one I can think of is 40, because 8 times 5 is 40, and 10 times 4 is 40. So I need to multiply this whole equation here by, well, if I want to get to 40, I need to multiply the whole thing by 4. So that means both sides of the equation by 4. And I'm going to need to do, for the second equation, multiply both sides by 5. So that 8 times 5 gives me 40. Okay, so here I'm going to do 4 times equation 1. But remember, I have to multiply both sides of the equation by 4. So multiply 4. So 6 times 4, 24. Plus 10 times, 24, and let's not forget the x. Sorry about that. 10 times 4 is 40y equals, and now 4 times 0.74. Let's check that out. So 4 times 0.74. Okay. Now let's do 5 times equation 2. Okay, so 5 times 15, that's 75x, plus 5 times 8, 40y, which is what we wanted, then 5 times 1, 5. Okay, so now the reason why it's called elimination is I'm now going to operate on these to eliminate the 40y's. Okay, so here I have a 40, I have a 40. I need to subtract the two 40y's in order to eliminate them. Remember, if I can't just subtract these two, I have to subtract everything. So I do 24x. So 24 minus 75. Okay, negative 51x. Okay, 40y minus 40y, 0. Okay. And so now 2.96 minus 5. So 2.96 minus 5, okay, gives me negative 2.04. But similar to before, now I have an equation that has only one variable. So I can solve this. X is equal to negative 2.04. And now divide the other side by negative 51. So x is equal to, so negative 2 by negative 51 is equal to 4 cents. Okay, 0.04, so $0.04 is the same at 4 cents. So here the cost for one apple, 4 cents. Okay, now we need to find y. So again, I can pick either equation here and solve for y. So let's say I pick equation 2. Okay, so 15 times x, but now I know that x is 0.04, so I can replace that in, plus 8y is equal to 1, and now I have to solve this equation. Okay, so here 0.04 times 15, so y equals 1, so 8y equals, bring the 0.6 to the other side, so we subtract it, so 8y is equal to 1 minus 0.6 is 0.4, so y is 0.4 divided by 8. So y is, and let's check that out, 0.4 divided by 8, and that's 0.05. Okay, so that means that the cost of one orange is 5 cents. Okay, so again, let's just recap. First thing to do is to determine what variables you're going to use. Usually that's found in the question. Use the sentences and information given to then solve and make sure you're solving for exactly what they're asking for. Here they wanted apples and oranges, so you have to solve for both. Okay, hope this helped.